Hello friends, in this series of lectures we will be discussing the previous year problems which were asked in GATE, ESE and other competitive exams. And these problems are related to electrical circuits and networks. So let's see this first question. The Thevenin's equivalent of a circuit operating at an angular frequency 5 radians per second and has it is given as open circuit voltage and an open circuit impedance are given. At this frequency, the minimal realization of the Thevenin's impedance will have options are given, so A, B, C, D options are given. So from this question we have to understand first what is Thevenin's theorem. So in electrical circuits and network subjects we have learned about several theorems like Thevenin's, Norton's, superposition, Millman's, Telegin's. All such theorems we have already learned in electric circuits and networks subjects. So in this question we have to apply the Thevenin's theorem concept. Okay, first of all I would like to make you understand. In a brief I will give an idea about Thevenin's theorem. For this question we need Thevenin's impedance. Okay, so for example consider this circuit. This is an example circuit I have given. This is not given in the question. This is only an example circuit. Okay, this circuit has to be converted to a Thevenin's equivalent circuit like which contains VTH and RTH. Okay, so according to Thevenin's theorem, we can convert a complex network into a simplified network with Thevenin's voltage and Thevenin's resistance across a given terminal AB. Okay, across the AB, if some in some question if they ask find the Thevenin's voltage and Thevenin's resistance across a terminal AB, then with respect to that terminal we have to find the Thevenin's voltage and Thevenin's resistance. Okay, then what is Thevenin resistance? Means open circuit resistance. That means while finding the Thevenin's resistance we have to consider all the voltage sources as short circuit and all the current sources as open circuit. With that condition and making all the other resistance remaining the same, we can find the Thevenin's resistance. This circuit shows that given circuit with the open circuiting the current sources and short circuiting the voltage sources, we can find the Thevenin's resistance. And with the same given circuit without making any changes, that means no need to short circuit or open circuit the sources. With the same circuit, find the Thevenin's voltage across A and B. Finding those VTH and RTH, we will discuss such problems in some other questions. For our question, what we have to find is minimal realization of Thevenin's impedance. Okay, anyway in the question they are given open circuit impedance. Open circuit impedance means what we have learned, this same Thevenin's resistance or Thevenin's impedance, open circuit impedance. Since the circuit consists of this means R isn't equal to R minus JXC form, right? That's why they told it as Thevenin's impedance. If only resistance were there, then we say it as resistance. If inductor, capacitor components are there, then we will be saying it as impedance. From the circuit, the only parameter we need is this isn't 0, isn't not, right? Open circuit impedance. All other notations given the question like open circuit voltage, angular frequency, we don't want to consider all those parameters for solving this question. The only one thing we have to see is the open circuit impedance, because they are asking about Thevenin's impedance. For minimal realization of Thevenin's impedance, what are the components we need? Like the resistor, capacitor, inductor. What are the components we need? From the given open circuit impedance, it is 2.38 minus J 0.667. From that we can understand it is in the form of R minus jXc. Okay, that means presence of resistor and capacitor is there. How we understood xc? How we understood means here the sign is minus. When the negative sign comes, that means it is capacitive reactance, resistance and capacitive reactance. If the sign is positive, then it will be inductive reactance. Okay. For the general formula of impedance is R plus J into XL minus XC. When there is a when the capacitor is absent, then the equation will become Z equal to R plus JXL. When inductor is absent, the equation becomes Z equal to R minus JXC. That means if the inductive reactance is less than capacitive reactance, then also in effect the value will be in the form of R minus JXC. Therefore, we cannot blindly say that there is the presence of resistor and capacitor, but there may be inductor present in the circuit. Okay, that's why I wrote this in the bracket. Inductor may or may not present. Because if the inductive reactance value is less than capacitive reactance, then in effect the formula again becomes R minus JXC form. The negative sign dominates. That means there may be inductor may be present or may not present. So again when comes to the question, it is written as minimal realization. Minimal realization means we need only minimum components. Okay, so it is better to avoid the inductor to make it a minimum realization. Avoid the inductor and only we need is resistor and capacitor. So answer is option B. Let's see the options. From the options it is we can see from option A it is written as resistor, capacitor and inductor. If they didn't ask if they ask just realization of the Thevenin's impedance, then option A is correct. Since they asked like minimal realization, so we have to answer it as resistor and capacitor. Inductor is not needed. Therefore option B is the right answer. Hope you understood this question. If you have any doubts, please ask in the comment section. Thank you for listening. Have a good day.